Hi everyone, great to be here, and thank you NC State for putting on this conference, and thank you for putting on the amazing weather. This is our third week in the US, and we started off in San Francisco, and last week we were in North Dakota and Fargo, and then Minneapolis, where, I think it was, if I got my conversion right, about 32 degrees Fahrenheit, so it's a welcome relief being in this weather, so thank you for that. So my name's Josh, I'm the co-founder of Caitlyn AI. We've been working to unlock research at scale using AI technologies, putting it into the hands of farmers, growers, researchers, those that can use it to drive things like practice change. In this presentation, I want to take you through how we're taking these large research archives and then basically all the way through to how we're actually supporting on-farm decisions and helping people with that practice change. So to do a little bit of an intro, as you can probably hear, I'm from New Zealand. We're from the South Island, the better island. I did some research before. People often say that, there's more sheep than people in New Zealand, right? And it turns out that's correct. So there's about 4.5 sheep for every single person in New Zealand. About 23 million sheep and 5 million of us. And we're also, we're tucked away down the bottom of the world and quite often forgotten about. So this is a postal world map that IKEA is selling, and as you can see, there's a blank space where we should be, but sometimes that's okay, with some of the events happening around the world, to be kind of forgotten about is not always a bad thing. But despite all of this, we are known for our agriculture. So primarily for our pastoral farming, so dairy, sheep, beef, cattle. If you look at our primary industries, agriculture, forestry, fishing, it does account for about 80% of our total exports. We are one of the world's largest dairy exporters, so about 30% of the world's global dairy trade comes out of New Zealand. And we do produce enough food for about 40 million people, which is not bad considering we're only 5 million. And we do have some really interesting ag tech companies coming out of New Zealand. So you might have seen that Halter, which is the collars for cows that allow us to have defenseless boundaries. They've been valued at $2 billion, and I think they've just raised 200 million. So there's some interesting bits and pieces happening over there. Now, to give you a bit of a story about us, so we're Caitlyn AI. We're a product that's been born out of an existing company. It's been around for about 20 years. So we're based in Christchurch, New Zealand, but we operate across Australia and now in the US. We're a team of about 20, so 2 in Australia, 1 in the US, the rest in New Zealand. We have worked to build bespoke software applications over those 20 years. And Caitlyn has been in market in the last 2 years. We work very closely with Amazon Web Services as our hyperscaler of choice as well. So to talk a little bit about the problem that we're solving with AI, it's all around research extension. Across New Zealand, across Australia, and as we've come to learn in the US as well, from checkoff programs to levy-funded organisations to research development corporations in Australia, there's billions of dollars invested every year into research, but very little of that, surprisingly little, can actually reach the end producer or the end farmer in a way that they can meaningfully use it. Farmers often need to make high-stakes decisions. Their livelihoods depend on this, and they need access to information that's local, that's relevant, that they can trust. And this information needs to be easy to understand. It needs to be presented in a way that they can digest it and apply it. And a large proportion of this information is often out there in the public, but it's time-consuming and difficult to interpret and actually apply in practice. So that's why we developed Caitlyn, which is our agentic platform. It's designed to take fragmented knowledge in the agriculture industry, combine it all together, and allow you to ask questions in natural language in your own way and get verified and trusted answers within seconds. And to show you what this looks like in practice, we'll start with a question, which is, how do you make over 30 years worth of agricultural research instantly accessible to your growers? So this is the foundation of Arable Research. They're a research institute in New Zealand that looks after arable crop farmers. They're local to us. They look after about 3,000 or 4,000 arable crop farmers. They have about 12 areas of major research, thousands of reports, many of them just sit on their website. Each report is an average length of 35 pages. And a lot of it is very, scientific and technical information. And, they came in to our office, I think, end of 2023, and they said, hey, look, this new AI technology, large language models, how can we leverage this within our organization to get better access to information. And so, they were very sort of pioneering and forward-thinking for the time, and we collaborated with them to build Caitlyn as a platform that was able to essentially take all of that information and allow their growers to ask questions of that in their own natural language and get highly precise and accurate answers within seconds. So their growers needed industry-specific and localized information. They wanted to be able to interact with it in their own way. They're time poor. They don't have time to search through highly technical reports and find information that's relevant to them. And it needs to be accurate. They need to be able to trust and rely on the information that comes out. So we implemented a solution which is called AskFAR. So it's a white-labeled version of Caitlyn that's available on the website. So you can go to far.org.nz and actually have a play with this tool. And this was released in 2024, which is pretty ahead of its time for this type of tool in the public domain. But basically, all of the 3,000 or 4,000 growers around New Zealand, or researchers, and students, are able to jump onto this tool and ask any question they like about arable crop farming in New Zealand and get very accurate and concise responses. And we saw almost immediately a 50% increase in engagement and a 90% increase in speed in terms of access to that information. So that was a case study, but how do we ensure trust into an AI system? So this is where we're starting to dive a little bit deeper into the technical side of things, but at a very high level, this is how Caitlyn's knowledge architecture is put together. So at the top, we have our knowledge pipeline. So each customer we work with brings their own data. It only uses their information that they supply, so it doesn't go off and use unverified information. So documents, PDFs, spreadsheets, videos, they go into the top, into our document processing pipeline. From there, we'll create either a vector store and or a knowledge graph, similar to what was presented in the last talk. The second piece is our agents. So these are powered by large language models, and we give our agents, all of the rules around tone of voice, the guardrails, what it can and can't do, its identity, how it retrieves the information, how it determines what's relevant and what's not. We have we call it the agent learning system, which is where we put in ground truth answers and can evaluate over time answer quality. Standard things like role-based access controls to what information people are allowed to access, all the way through to a user interface where people can actually ask questions of the system. So in terms of how we ensure trust, well, we need to make sure that the information is relevant and it's localized. So that's why we work with organizations that are able to supply their own verified knowledge into the system. We do metadata extraction, so the knowledge that's coming in, the documents, we actually pull out key bits of information like publish dates and authors and regions, and we can use that to filter across thousands or tens of thousands, even bigger sizes of in terms of number of documents to find the most relevant information. But the key to ensuring trust is the citations, which you can see in that screenshot. So every passage or piece of text can be traced through to source material that the AI has drawn upon to inform the response. And we also do quite a bit of agent tuning with subject matter experts to de-risk hallucinations and increase the accuracy. In terms of guardrails, which are the safety frameworks, the policies, the control mechanisms that constrain the AI models, we learned very quickly that building for agriculture is often building for nuance. So, for example, ryegrass can be a crop, but it can also be a weed, or sunflower can be a brand of machinery, or it can be an actual crop that you're trying to grow. So, how do you know exactly what somebody's asking about? So, our agents will often ask clarifying questions to make sure that it properly understands the context of a question. So a lot of scoped boundaries in what the AI can do. We also tend to set up Caitlyn in a dedicated tenancy for each of our customers, so there's full control over IP and the data that's in the system. And we also use escrowed models, which means that we use models that are sort of held in almost like a sandboxed environment by AWS, which means that we're not sending information directly to Anthropic or OpenAI, so there's no risk of that being used for future training data for models. And if we dive even deeper again, in terms of that knowledge architecture, the technique that Caitlyn's using under the hood is what's called Retrieval-Augmented Generation. What this really means is that the information that goes into Caitlyn is converted to a series of numbers that we call vectors, which is really the semantic meaning of the information that goes into Caitlyn. So when you ask a question, the question that you ask is also converted into vectors. And then essentially what it's doing when it retrieves the knowledge from the knowledge base is it's doing a similarity search or matching, and it's bringing back the most relevant or the most semantically similar content, which the large language model will then use to process an answer. Now this works pretty well, but there are some limitations, and especially when you're working at scale. One of the big limitations is that when it's doing that retrieval process, it's bringing together lots of pieces of content, lots of chunks of content, independently. It doesn't really know the relationship between each of those bits of content. So if you've got 100,000 documents and you're pulling together lots of pieces of content, it doesn't understand that, that they all look independent to the large language model. So we call it being context blind. It also, at scale, there's a lot of computational effort that's required to calculate and process the information. And essentially, if you're searching, if I use the ryegrass example, it'll be basically looking to find every single piece of content that matches or has a score against ryegrass, which may actually include irrelevant results, which then needs to be filtered out. So we've started to introduce knowledge graphs into Caitlyn to provide even more precision. And what this really means is that instead of asking what paragraphs are similar to my query or which pieces of content are similar, we're now asking what content discovers the concepts I'm asking about in context of the particular domain, which may be some subset of agriculture. So in terms of how this works, when we're bringing in the documentation, we're extracting different entities. There might be crop types, there might be diseases, there might be fungicides, and we're mapping those to an ontology, the concepts within an ontology. Then we're creating document nodes, section nodes, concept nodes, and then mapping relationships between those, which essentially means when somebody asks a question, we're able to traverse that graph and pull all of the related pieces of content that essentially map to those entities. So it's very precise in the information that we bring back and provide to the large language model, and we can rank that by relevance and the relationship strength. A concrete example of this is that if I ask the question, what fungicides are effective for striped rust in wheat? Essentially what we're able to do is pull out the concepts the concepts in that question. So the fungicides, striped rust is the disease in wheat. And then when we're traversing that graph, we can go striped rust affects wheat, which is treated by a fungicide, and we can pull out specific documents that actually mention all three of those concepts, which means that from that retrieval process, we're able to bring together highly accurate information and then produce an answer from that after our ranking process. If you compare that to vector-RAG, what would happen in that case is that it may pull together anything that is semantically similar to striped rust, same with wheat, but you might actually get striped rust in a different type of crop that you're not looking for. So that adds a lot of extra load for the large language model to filter all that out and produce an answer. And then to really turn that from good to great, we use pre-existing ontologies. So for agriculture, we use the NOLT ontology, which is really like a giant thesaurus of about 77,000 different concepts provided by the USDA, which covers crops, diseases, treatments, and so on. The really nice thing about this is that we're able to, for example, if your documentation mentions perennial ryegrass or it may refer to as PR ryegrass, it's able to map different synonyms to concepts in the ontology. It also means that we can work with hierarchical content or concepts. So, for example, if somebody's asking about grain crops, we can, kind of map that down to different types of grain. So, wheat, cereal, so on. And this is a lot of the secret sauce that we built into Caitlyn that allows really highly accurate and verifiable answers that more generic tools like ChatGPT just aren't able to do. And I guess the key takeaway I want to leave you with is, all of the research out there, and that there's a lot of data out there, what good is that research if you're not able to bring all of that and supply that to the people that can use it most? And that's what we're working to do. So thank you very much.
I'm both moderator and last speaker, so I can say, let's take one question if you have one for Josh. Over there, just give me a shout it out.
Sure. So I don't agree with the last statement that you said that ChatGPT can't make the decisions, because I'm from Nebraska, so we planted corn. So we ran a farm completely with the decisions made by ChatGPT in the last 2 years. And first year we learned something, how to use it, and made decisions starting from high simulation, irrigation, fertilizer application, irrigation, as well as grain marketing and insurance selection. So everything is made by ChatGPT, and our farm got the highest review. So I think there is the models like OpenAI models, Anthropic, like these models are well trained, as well as they are trained in the way that providing the best answer in the correct way with the logical flow. So do you think you can compete with it?
Well, yeah, I mean, oh,
Quickly.
oh yeah, I'll keep this quick. I'd actually love to talk to you more about this after this. I guess we use the same foundation models under the hood, so a lot of the secret sauce that we have is around the context engineering and also the data that goes into that to provide the most precise, accurate, localized answers. So we are essentially using the same technology, but in our testing with our customers, we've found that ChatGPT can often, and I'm talking out of the box, not in any sort of other solution, can often give incorrect information simply because it's not drawing from a localized set of information. So, but I would love to understand that in more detail because it is a really fascinating space that's evolving very rapidly. Thank you.
Thanks again.